Alright, day 5. This time I promise we're going to get done in 15 minutes. Make sure we read what's written down here if you want your extra credit, and let's get started. So number 1, last 4 days Patrick has been studying a lot. He studied for 3 hours, for 2.5 hours, 1.5 hours, and 3 hours. And we want to know what is the average time he spent studying. So remember, when we say average, we have to add all the numbers up and then divide by however many numbers we have. So a couple ways we can do this. We could turn these all into decimals, but if I look at the fractions we have, we can do this a simpler way. We can say if we have 2.5 plus 1.5, we can add these fractions together because 1/2 plus 1/2 is just 1 whole. So 2 hours plus 1 hour plus this extra hour gives us a total of 4 hours. Now we add that to what we have here, so it's 3 hours plus 4 hours plus 3 more hours, and that gives us a total of 10 hours. So he spent a total of 10 hours studying. But now we want to know the average. So we need to divide that by however many days he counted. So we have 1, 2, 3, 4 days. So we need to divide 10 hours by 4. So we take 10 and we divide it by 4. 4 will go into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. Since we don't have any numbers, we add a decimal, and a 0. 4 will go into 25 times, and that will finish up our dividing here. We are out of numbers. So 2.5, so that is his average. His average 2.5 hours. And now we could turn this back into a fraction if they were asking you for that. 2.5 would be the same as 2 1/2. Alright, so there's number 1. Remember, this was Patrick. Alright, number 2. Class of 50 students, 20% had brown hair. Of the remaining students, 30% of them had blonde hair. So this is kind of a 2-step problem, and probably the one that'll take the most time today. So one of the key words here is it says the remaining students. So when we say 30% are blonde, it's not 30% of 50, it's actually 30% of the kids that don't have brown hair. So what we need to figure out first is how many of our kids have brown hair. So let's have our kid here, and he's smiling, and he's got brown hair. He is 20% of the class. So remember what we keep saying. I'm going to keep repeating it until you're tired of hearing it. If we have percents, we can use a proportion to figure this out. So we're looking at kids with brown hair as compared to the total. We can fill in the numbers in our proportions. We're going to have numbers on one side, percents on the other. We know our total percent is going to be 100, and we know the percent that has brown hair is 20%. We know it's a class of 50, which now that I think about it is a lot of kids put in one class, but our total is 50 kids. We don't know how many have brown hair just yet, so here's our proportion. We can cross multiply. You could simplify this first, 20 over 100, but let's leave it like this, just for fun. So we have 20 times 50, and that's going to give us 1,000. We take that number, we divide it by 100. And how many times can 100 go into 1,000? Well, if you just count by 100, you get 10. I do this math all the time with my wallet. If I've got 10 $100 bills, then I have $1,000. Because I got paper like that. Don't laugh, you know I got paper like that. Yeah. So this means we have 10 kids with brown hair. But we don't actually care about those 10 kids. We want the kids that don't have brown hair. So if 10% do, we can say if we take the rest of the class minus the kids with brown hair, that gives us 40 kids that don't. And now we can do the second part of our problem here. So 20%, that's 10 kids brown hair. Now of those remaining, 30%, whoops, supposed to have yellow hair, not a yellow head. So 30% of the remaining, that's kind of hard to see. Let's give him curly blonde hair. So we want 30% of our 40 kids. So again, we can set up another proportion just like this, only instead of comparing brown to total, now we're looking at blonde. Blonde to the total. Okay, again, our proportion is going to look a lot like this. Still 100% on the bottom. 100%. This time we have 30 on top. Our total number of kids here is 40. And the number blonde, we're not sure of just yet. So again, we can cross multiply. We can say 30 times 40. And that would give us 1,200. We can divide that. Actually, before we do that, just in case you forgot why I can do this so fast without having to go through it all, since both of these numbers end in 0, we don't have to multiply everything. If we just say 3 times 4, I know that's 12, and then I just add the total number of zeros to the end. So there's 2 zeros here, so 12 plus 2 zeros is 1,200. Okay, alright, so 1,200 divided by 100. We've got extra zeros on both of these. We can cross them out. 2 zeros on both, cancel each other out. 12 divided by 1 is 12. So that means we have 12 kids with blonde hair. So there is our answer. 30% of the remaining kids is a total of 12. So far so good, hopefully. Alright, number 3. So we got a triangular base of a prism is a right triangle with sides of 6, 8, and 10. The height of that prism is 4.5 feet. What is the volume of the prism in cubic inches? Okay, well, one thing we got to look at here is this is talking about inches, but over here we have feet. Hopefully we're starting to get more familiar with how to go from feet to inches. We know 4 feet, well, if 1 foot is 12 inches, that would mean that 4 times that much, 4 feet, would be 48 inches. 48 inches. And then half a foot, if a whole foot is 12 inches, then half of that would be 6 inches. So if we add these two together, we get a height of 54 inches. So instead of saying 4.5 feet, we can say 54 inches. And let's make this a little bit smaller so it's not in our way while we do the rest. Maybe. There we go. Okay, the other part of this that's going to be a little bit confusing is trying to figure out which part of the triangle is which? We know we have a right triangle. So let's draw ourselves a right triangle here. And it says it's got sides of 6, 8, and 10. Well, how do we know which side is which? Hopefully remember that on a right triangle they had special names where the two sides connected to the right angle were the legs, and this opposite side was the hypotenuse. And the hypotenuse was special because we knew it always had to be the longest side. So if we look 6, 8, and 10, the longest side would be 10 inches, so that's got to be over here. And then 6 and 8, it could go either way. I could put 6 over here, 8 down there. I could switch them around if I wanted to, as long as they're the two sides connected to the right angle. The reason we need to know that is because now to find the volume of this, remember volume is the area of the base times the height. And I guess we can finish drawing our prism here. Oops. That doesn't look so good, but you get the idea. This is a triangular prism. And we know the height of this, we said, was 54 inches. Okay, so let's fill in what we can. So the area of the base is going to be this triangle. So to find the area of the base, we would need the formula for area of a triangle, which is 1/2 of the base times the height. Now we say base and height, we're just talking about this triangle. So the base and height of this has to be these two sides connected to the right angle. It's got to be 6 and 8. So we're looking at 1/2 6 times 8. We can do that math out. 6 times 8 is 48. 1/2 times 48, or 48 divided by 2, or half of 48, however you want to say it, will always come out to 24, which means the area of our base is 24. So we can take this number, put it back into our formula, and say that big B is 24. And then the height of the whole prism, which we figured out at the very beginning, is going to be 54. So to find the volume, we just multiply these two together. So working really hard, we can say 54 times 24 equals 1296. And that's cubic inches, so we can call that inches cubed. So there is our answer. Alright, 3 down, 2 more to go. Alright, Mrs. Puff. Mrs. Puff. She's taking a trip from Corpus to Victoria. And he, I guess that should say she since it's Mrs. Puff. She measured the distance on the map and found it to be 3.25 inches. The scale on the map says 1/2 of an inch equals 15 miles. What is the actual distance between the two cities? Okay. Well, anytime we start talking about measuring on a map and looking at a scale, that's just another example of a proportion problem. So in this case, we're comparing, it's pretty straightforward, it's just inches as compared to miles. Okay, miles. And we can always start out by looking at the ratio that the map gives us. So 1/2 of an inch is 15 miles. So 15 miles go on the bottom. Now I don't want to put fractions in my fraction, so I don't want to put 1/2 here, so I can turn that into a decimal. That's going to be 0.5. So it's going to be equal to. Now we look back to the problem and say, what do we know? What does the problem tell us? Well, it says it's looked on the map and got 3.25 inches. So we put that on top of the inches. the question says what is the actual distance, so that's going to be in miles. So we don't know that, we can call it x, or d, or c, or I, or whatever letter you like best. But here is our proportion. So we can cross multiply. So we can do 3.25 times 15.
Oh, it's 15 minutes. Your time's up.
Don't. I'm never going to get this done in 15 minutes. Okay. I get it. I'm slow. Multiplying. 5 times 5. 5. 25. I don't know. I'm flabbergasted that I can't do 5 problems in 15 minutes. Flabbergasted. Are there 2 B's in flabbergasted?
I have no idea.
Me neither. Flabbergasted.
Kids probably don't even know what that means.
Flabbergasted. Okay. We'll look that up at the end. 25. This is 12. 16. Second number we bring down a 0. Multiply this by 1. That's pretty easy. 5, 2, 3. Add them up. That's 5, 7, 8, 4. We have 2 decimal places up top. We need 2 decimal places in the answer. So 4875, we need to divide that by 0.5. Let's pick a different color here. So we have 48.75 flabbergasted divided by 0.5. We never want to divide by decimals, so let's move it over 1 place. So instead of dividing by 0.5, now we're dividing by 5. And that's going to go into 487. Okay, so 5 goes into 4. 5 can't go into 4. Get rid of my old decimals. Can't go into 4. So go to 0. Goes into 48 9 times. 9 times 5 is 45. 3 left over. Bring down the 7. 5 goes into 37 7 times. 35 there. 2. And 5. 5 goes into 25 5 times. So we get 97.5 miles from Corpus to Victoria. And let's see how accurate I am. If we go to our Google Maps calendar, here is Corpus, and there is Victoria, out in the middle of nowhere. And it is 97.4 miles. So we were off. I got a yay in the background. I was off by 1/10 of a mile. So Mrs. Puff, pretty good at reading a map. Flabbergasted. Alright, number 5. One more. This is going to go quick. I promise. We're reflecting a point. So let's start with a little coordinate grid. You can label it. Here's Y. Here's X. -2, -9. If we had to pick a quadrant for that to be in, well, we can't really pick. It has to go somewhere. We have to think what quadrant has X negative and Y negative. Well, X is negative on the left side, Y is negative on the bottom side, so it's got to be somewhere on the bottom left. Yes, it is quadrant 3. Very good answers from the other room. -2, -9. She wasn't even looking at the plot, she says. She's amazing. We're reflecting that across the Y, or not the Y-axis, the X-axis. So we're going across this line here. So if I reflect this point, it's going to go to the other side of that line. So it's going to go from quadrant 3, it's going to move all the way up to quadrant 2. So our point would end up somewhere over here. So let's think, how do our coordinates change? Does our x value change? Did it move from left to right? No, it's still in the same spot. It's still -2. We look at our y coordinate. Did y change? Yeah, y changed like a lot. It went from all the way down here to all the way up here. Since y is above the line now, it's in the positives. So instead of being -9, it is now +9. So our new coordinates are -2, 9. That's it. There's your homework. Couple notes for anyone. You probably figured out on this tablet, if I make two dots far apart, it makes two dots. If I make two dots close to each other, it decides I really wanted to make a line. But I don't really like making lines. And that's why my stuff gets messed up. It leaves me, you know what it leaves me? Flabbergasted. Alright, let's look up flabbergasted on the Wikipedia. Because who doesn't want to know what that means? Wikipedia.org. Flabbergasted. The page flabbergasted does not exist.
What?
How sad is that?
What is the real word?
Obviously, I made the word up.
No, you didn't.
Okay, I did some off-screen work to find out the definition of flabbergast. And here it is. To cause to become overcome with astonishment or to astound. There you go. Oh, can I make it say flabbergasted? I'll be so excited.
Flabbergast. Flabbergast.
Nice. Can I say it in British?
Flabbergasted. Flabbergasted.
I could do this all day. Alright. No, I can't. I'm out of time. Thank you for watching. Be sure to like and subscribe. And once I figure out how to make a Twitter, you should hit me up on Twitter. Alright, good night.